Hello, my name is Bethany Wright. Presently, I am a teacher's assistant in a 7th grade math classroom. But prior to that, I actually worked at an alternative high school in DeKalb County for approximately 2 years. And after leaving there, I worked for the Princeton Review doing SAT and ACT instruction. So today what I'm going to do is I am going to go over a geometry-related SAT problem that is considered one of the harder problems on the SAT, and I'm going to give you a strategy that shows you how you could work through this problem to figure out the correct answer. The problem is as follows. In triangle ABC, the measure of angle B is 90 degrees. BC is equal to 16 and AC is equal to 20. Triangle DEF is similar to triangle ABC, where vertices D, E, and F correspond to vertices A, B, and C, respectively, and each side of triangle DEF is 1/3 the length of the corresponding side of triangle ABC. What is the value of the sine of angle F? Alright, so for the stop and go approach, we're going to stop at words, sentences, or phrases that are important. So as an example of a word or a phrase or a sentence that's important, anytime we see a number or a variable or math-related vocabulary, we need to stop. You can underline this vocabulary or these numbers, or you can circle, or you can even draw a picture if you need to. For geometry, the thing I always tell students is to draw a picture because it will help you visualize and understand the problem so much better. So let's use stop and go. In triangle ABC, we can stop right there because we know that there's a triangle, so we can draw a triangle and make sure that its vertices are labeled A, B, and C. The measure of angle B is 90 degrees. We'll stop right there again. Now, sometimes when you use the stop and go approach, you do have to revise what you've previously drawn or written. Now, I know that the measure of angle B is 90 degrees, so I know that my triangle is going to be a right triangle, and the measure of angle B is going to be 90 degrees. BC is 16, so I'm going to label BC 16. AC is 20. Triangle DEF is similar to triangle ABC. We stop there because similar is a vocabulary word. That means that these triangles are alike, but they're not exactly the same size. So I know that triangle DEF is similar to triangle ABC, where vertices D, E, and F correspond to vertices A, B, and C, respectively. So I'll just go ahead and draw that out to make sure that I have the right image. D, E, and F correspond to A, B, and C. So that means that D would be placed where A is, E would be placed where B is, which also means that E is a right angle, and F will be placed where C is. And each side of triangle DEF is 1/3 the length of the corresponding side of the triangle. So when we're looking at this, we have to understand what corresponding sides mean. BC corresponds to side EF, AC corresponds to side DF, and AB corresponds to side DE. Now if we go back in the problem, it'll say that each side of triangle DEF is 1/3 the length of the corresponding side of the triangle. If we look back at ABC, we see that we only have 2 sides of a right triangle instead of 3. So how do we figure out the length of the third side? Well, anytime you're dealing with right triangles and you need to find the length, you need to use the Pythagorean theorem. A squared plus B squared is equal to C squared. I don't know what this side is, so I'll just call that A for the sake of this problem. And I'll call this side B, and I'll call this side C. doesn't necessarily have to be labeled this way. The only thing I'd like to say about these types of problems is that your side C should always be the longest side of a right triangle. It should always be the hypotenuse. So we have a squared plus 16 squared is equal to 20 squared. 16 squared, or 16 times 16, is 256. 20 squared, or 20 times 20, is 400. So now we pretty much have an equation where we can solve for the unknown variable a. We subtract 256 from both sides. These cancel. And 400 minus 256 is 144. Now, if you're using a calculator, it's very simple to figure out what a is, but using inverse operations, we undo a square by taking the square root of both sides. The square root of 144, because we're talking about lengths, we are only considering the positive square root, is going to be 12. So this side right here is going to be 12. So now that we have the lengths of all of our sides, we can go ahead and figure out the lengths of DEF. However, the question that they want us to answer is, what is the sine of angle F? So I'm going to show on this triangle what angle F looks like. And I know that this is angle F. And since they're similar triangles, angle F corresponds or matches to angle C. And I know that if I can figure out the sine of angle C, then that will be equivalent to the sine of angle F. So, let's figure out the sine of angle C. If you remember SOHCAHTOA, the sine of any angle is opposite over hypotenuse. The opposite side is 12. So I'll go over here and write the sine of angle C. Opposite is 12. My hypotenuse is 20. And always get into the habit of simplifying your fractions if needed. 12 over 20 simplified is going to be 3 over 5. So if the sine of angle C is 3 over 5, then the sine of its corresponding angle, angle F, is also 3 over 5. So the sine of angle F is 3 over 5 as well. And that is how you solve a problem such as this. Thank you so much for your time.